Welcome. I am Anna and I am at the School of Biosystems and Food Engineering. This is a quick practical guide on how to use superhuman machine-enhanced vision for your experiment, hyperspectral imaging. This video is a short guide to the high-specs imaging equipment that is available for researchers and students in the school. I'm going to cover 3 topics. First, the technique. What is hyperspectral imaging? Second, the equipment and the documentation you need to know to use it. And third, an example. What can you do with it? What is hyperspectral imaging? If you're going to use the equipment, you are already familiar with the term. Hyperspectral imaging is a technique that combines spectroscopy and imaging. We can use spectroscopy to study the chemical information in a sample. And we can use imaging to identify objects, regions of interest, heterogeneity, etc. In hyperspectral imaging, we have both. And this means we can use it to obtain a map or an image of chemical information in your sample that may be invisible to the naked eye. Let's have a look at the equipment. Follow me. This is the high-specs hyperspectral imaging we have in the school. It is a push-broom system. This means it works like a scanner, scanning the samples line by line, like an office scanner would do. When we take an image, the cameras stay still and the table moves, allowing us to scan the samples. It is composed by 3 components. The cameras, this is the SWIR camera and the VIS camera, the lighting system, which has focused lights, and the stage, which is the moving platform where we place the samples. In addition, the system is connected to a computer and to a stage controller. How to use it? Read and follow the documentation. There is a basic user guide and additional documentation for advanced users. Before continuing watching this video, please make sure you have your basic user guide at hand. Follow the guide step by step to switch on the equipment in the right order. Place your white references and your samples correctly. Optimize your acquisition parameters and take the hyperspectral images of your samples. Save your files, switch off the equipment, and wrap up your experiment neatly. You can find every step explained in detail in the guide. What I'm going to do here is to highlight some crucial points that you need to know to make the most of your experiment and mind the equipment. Point 1, lighting. Verify the lighting. If you're measuring with both cameras, please make sure that both cameras and both lights are focused on the same line on the table. If they are not, ask an advanced user to fix that. Point 2, references. White references are very delicate and very expensive. You need to handle them with care and very, very importantly, with gloves. And point 3, timing. Give yourself plenty of time for the experiment. You need to set up your acquisition parameters in advance. It takes longer than it seems. Also, you need to take into account that once you switch on the equipment, you will have to wait for 1 hour before you can acquire your hyperspectral images. Do you want to see an example? Let's see what the equipment can do. These are our samples, 5 different types of polymers. This is how the scanning process looks. And these are the results we can obtain from the analysis of the images. What do you need to remember? Instructions. Everything is detailed in the instructions. Follow them step by step for the sake of your experiment and the equipment. Equipment. Handle it mindfully and with care. Book it in advance and do not change the setup unless you're an advanced user. And finally, planning and timing. There is a lot you can do with data analysis, but there is no substitution to getting the best data you can get from your equipment. And for that, you need to plan well and with plenty of time. Welcome to hyperspectral imaging. Good luck with your experiments.
Yeah.